This is Lab 25, Example 2. We have the system of equations, negative 3x plus y minus z is equal to 2, x minus 4y minus 7z is equal to negative 4, and x plus 2y plus 5z is equal to 1. We're going to use this system of equations to answer parts A through D. For part A, it asks to find the coefficient matrix. So just like example 1, we're going to look at all of our variables. We have the variables x, y, and z, and we're going to ignore the right-hand side, which is just constants. And we're going to write all of the coefficients in a single matrix. So we have, for the first row, we have the coefficients negative 3. In front of y, we just have 1. In front of z, we have negative 1. And for the second row, we have 1, negative 4, negative 7. And for the last row, we have 1, 2, and 5. So again, this first row is the first equation, second row is the second equation, and the third row is the third equation. And each column corresponds to each variable. So this is the x column, this is the y column, and this is the z column. So this is our coefficient matrix. For part B, it asks us to find the determinant. This is larger than a 2 by 2 matrix, so even though it is in fact a square matrix is when you have the same rows and the same columns, so you have a 3 by 3. It will be a little bit more difficult to find it algebraically, so we're going to use our calculator. So turning the calculator on, we're going to go to our matrix menu, second x to the negative 1, scroll over to edit. I'm going to edit A. This is a 3 by 3 matrix. We have 3 rows and 3 columns, so I'm going to change the size to 3 by 3. It added another row there. I'm going to enter all the numbers in our matrix here. So we have negative 3, we have 1, we have negative 1, we have 1, negative 4, negative 7, 1, 2, and 5. So now we've entered all of that, we're going to go back to our home screen, so second mode to quit back to our home screen. And we want to find the determinant of this. So we're going to go back into our matrix menu, so second x to the negative 1, scroll over to our math tab. The first option is where it says DET in parentheses, that stands for determinant, press enter. We need to enter the matrix to find the determinant of, so second x to the negative 1 to go back into our matrix menu. We edited A, so press enter for the first one, which is A. So we want to find the determinant of matrix A, press enter. And it says our determinant is 0. So here for part B, we have D is equal to 0. So moving aside, so moving on to part C. Part C asks to find the reduced row echelon form of the augmented matrix, and then it asks, is the system consistent? So we're going to find the augmented matrix. Previously found the coefficient matrix. The augmented matrix adds the constants columns. So we have the augmented matrix of negative 3, 1, negative 1, and then adding this column right here, we have 2. So this is the first row, negative 3. In front of y is 1, negative z is negative 1, is 2. And for the second row, we have 1, negative 4, negative 7, and then negative 4. So it's essentially the same as finding the coefficient matrix, except we're just adding this column right here. And again, for the last one, we have 1, 2, 5, and 1. So this is our augmented matrix right here, which is different from our coefficient matrix. And we want to find the reduced row echelon form of that. So we're going to go back to our calculator. We're going to go back into our matrix menu, so second x to the negative 1. We're going to go to our edit tab. We're going to edit matrix A. Our new augmented matrix is a 3 by 4 matrix, so we need to change the size. So this is 3, and then change the last 3 to 4. It adds a column to it. We have all of the numbers here being the same as our coefficient matrix, but we just need to add this last column here. So I'm going to scroll over to here. We have 2, and then we have -4, and lastly we have 1. So our matrix now looks the same as our augmented matrix here. I'm going to go back to our home screen, so second mode to quit. We want to find the reduced row echelon form, so going back to our matrix menu, second x to the -1, scroll over to the math menu. You're going to scroll down until you see RREF, right, like that, not REF, but RREF. Press enter. We need to enter the matrix that we're going to find the RREF of, so second x to the -1. We edited A, press enter, and it gives us the reduced row echelon form of our matrix that we had here. So, just writing what this is down, what we got. This is 1, 0, 1, 0, 0, 1, 2, 0, 0, 0, 0, 1. So just like example 1, we can retranslate this back into a system of equations. So if we do that, we get 1x plus 0y. I'm not going to write that, but this is plus 0y. This is the x column, y column, z column, and then the right-hand side, or the constants column. So we have plus 1z. This is equal to the right-hand side, which is just the constant, so this is equal to 0. And then for our second row, we have 1y plus 2z is equal to 0. And then for our last row, we have 0x plus 0y plus 0z, which is all equal to 0. So we have 0 is equal to our right-hand side, which is 1. So I just want you to look at this for a moment and realize that this very last row is ridiculous. We have the number 0 is equal to the number 1. This is false. This is not true. So because this is not true, we know that our system is inconsistent. It is not consistent. It is an inconsistent system because we got a ridiculous answer right here. We got a ridiculous statement. This last row says 0 is equal to 1. So it is inconsistent. And moving on to part D, says, what does the determinant D being equal to 0 or not equal to 0 tell us about each system? So we found our determinant is equal to 0, and we found that our system is inconsistent. And this is actually true for any matrix where our determinant is equal to 0. It means that our system is inconsistent. If our determinant is 0, we have an inconsistent system. If our determinant is not 0, then we may have a consistent system.